Good morning. This is Mark Woolbright. Welcome to the blog. Today I'm going to add in a short video clip about the work that we're doing at Southern Illinois University at Edwardsville with Dr. Retzlaff. I hope you enjoy it. This will be the first in the series. You'll get a good idea of what we're doing over there and what we're getting out of it, and I'd love to hear your feedback. Yes, I've managed to get a summer cold, but I'm not going to let that stop me. So it's a beautiful day and the season's awesome. There's lots of things blooming. It's my favorite time of year. Take care.
That's Dr. Retzlaff over there, and he's examining all the walls. And Dr. Retzlaff is here at SIUe Edwardsville in their environmental science program, and he heads up this test site. He also does extensive green roof research, and he's got another green roof test site here on the campus. And he generates a lot of data on what works and doesn't work and publishes it, and that's precisely what we're doing with these green walls. And we have filled these sample walls, test walls if you will, with bottom ash blended with organic material. For those of you that don't know, bottom ash is a byproduct of coal-fired electric production, and this is a solid byproduct that there's really not a use for, so it's a 100% waste stream product, and we take it from the power plant, blend organic material into it, and use it as unit fill. And we're testing for a variety of theories here at the SIU program. Here we've got one of our blank replicants here with nothing ever planted, and then right next to that we've got a green spurium, and we've got Dr. Bill. And Dr. Bill's showcasing another one of his famous hats. He has failed to kill the plants in this wall, which isn't always his goal, but it's the outcome when you get the wrong plant species in there. And then we can document exactly why it was wrong and why it didn't give us what we'd like in a commercial setting. And then we know how to make adjustments in the advice we give and the way these structures are specified. You can see this has come out of dormancy nicely, and you probably won't see the face of the blocks at all in another probably 2 months. They will really move quickly. You see how they're growing so well in each of the pockets and trailing down the edges. And then this is Sedum kamchaticum, same type of thing, pretty large variety of sedum, and it has been known in our actual real-world applications to totally cover a wall to where you don't see the blocks. It's a good performer. And we've got our test wall again. Wow, it's amazing how nothing grows in this. So the sedum will flourish in this, and weeds will not, which is one of the things that we were interested in quantifying. Yeah, this is one of the test replicants. We've got 3 of each species. This one's got green spurium in it, and in all 3 of these test walls has done pretty well. And you can see, you know, we're in late April 2010. And we've actually had warm temperatures and a drought, and we're about 3 inches low for rainfall so far this year. You know, these things really haven't hit their stride just yet. They've gotten a lot of heat with no water early in the season, so it's been tough growing conditions for these guys. You can see right next to it we've got one of our control walls, and this shows our blended bottom ash as backfill. This has been here for 3 years, and nothing grows in it, not a weed, nothing. And it's not erodible. There's no erosion in the pockets in any of these test modules here. Nothing has left it. And this is exactly the same material that all this grows in, which is very interesting, and provides us a nice control. And this is kamchaticum, another variety of sedum, and these things just got a little bit of fertilizer. We're waiting on a little bit of rain, and these things should cover over the wall this year.